right, here's some answers for those. Better than yesterday, same. They got worse. Questions? Number 4? Yes. Anybody need another moment with the answers up there? I was going to look at number 4. All right, so number 4. First thought on number 4 is it's a fraction divided by a fraction. So maybe my first move would be to copy dot flop. So it would look like this. 5x plus 30 over 2x times the reciprocal of the second factor. So far, so good? Okay, so it says simplify, and that's a really key instruction right there. That means that everything needs to be in the Did I mess something up?
Yeah, it's
minus 20.
Oh, thank you. So I was going to run into that problem here in a second when I tried to factor this thing. Thank you. So anyway, so simplify, that means it needs to be reduced to its most simple conceivable form, because the truth is, if all I was going to do is multiply, I could just multiply the numerators times each other, and I could multiply the denominators times each other, and that would be a product, right? I would have completed the process there, but it would not be in the simplest possible form. So in order for me to simplify this, I can do one of two things. I can either multiply it like I just proposed, and then try to reduce stuff, and I say almost always that is going to be the harder road to deal with. Or I could try to break it down now, reduce it now, and then finish a little bit easier. So the only way that I can tell how to simplify this is if everything that I have is broken down into its prime factors, the simplest possible numbers and expressions. So I look at this one here, and this one here, the 2 times x. 2 is prime, times x. That's a prime factor too. So I'd say the 2 times x's, they're both already prime. But the expression in the upper left and the lower right, those are not prime because they can still be factored down into a simpler form. Whenever you're going to factor, what should be the very first thing you think about?
GCF.
Yeah, so upper left,
5.
5 is the GCF. Yeah, so it'd be 5 parentheses x plus 6, all divided by 2x times 2x over...
You could use box method.
Yeah, so there's no GCF, right? So we always want to think about the GCF first. There isn't, and so you use the boxes. Have any of you guys kind of moved past the boxes?
Yeah.
Maybe you have. If you have, that's great. You don't really have to have the boxes. So whatever method you need, but we need to factor it. So whether you use boxes or not, or some other method, this would be your factoring right here for that one. And I think once you get down to the point where everything is factored, that's when you can start simplifying stuff. The C word, cancel. So at this point, what I would do, Colton, is I would recognize that I can cancel out the 2's, so they divide out. This x is a factor, cancels out with that x, which is also a factor. And of course, the x plus 6's would cancel with the x plus 6's. So the whole factor cancels or divides out with the other one. So in the numerator, I'm only left with a 5. And in the denominator, an x minus 4. Where did it go wrong?
I told reducing the x squared plus 2x minus 24.
Oh, factoring that out? Okay. Does that help?
Yeah.
I didn't really show you the details. You want me to show you the details on
I
that?
know what to do, like either factor it, use box method, so. Is that you?
Okay, yeah, so this is a quadratic.
Yeah.
And once the quadratic, like once the GCF had been brought out of a quadratic, then the 4 boxes would be a good method. Yeah. Okay, there's number 4. Anybody else with 1, 2, or 3? Small questions, minor details, anything? Nothing. Okay, fair enough. So what I'm going to have you guys do now is grab a spot at the board.
Two times the head starts with 2 times 3.
All right, please try that one. Ready, go. There you go. Hey, I misspelled X. Give me a break. That was funny. You're all just like, nope, not funny.
Nothing was wrong with Ukraine, but you don't want to go back? Nothing was wrong with Ukraine.
Negative 2/3 was the right answer. You did well. Negative 2/3? Yeah. All right, so let's focus in on a couple of new things, and we'll probably find ourselves back at the board in a few minutes. So, I thought based on what I would say is your demonstrated expertise with what you just did, maybe you could do number 1. So please try number 1. Check with a partner as you work on this one. See if you all agree on a process and a solution for number 1. And we'll kind of see where you stand, and we can fill in some gaps as needed. But please do kind of partner up. So maybe Jaden, you and Ava could discuss at some point, and I guess everybody else is pretty close to someone. So, okay. For the video, for the folks that might watch on the video. So walking around, I saw everybody started off with a common denominator, which I think is a great move. What was your common denominator? X plus 3 times x plus 1. That's right. So it's for the left side, you're going to have to multiply top and bottom by x plus 1. Thank you. And for the right side, multiply top and bottom by x plus 3. Right? So I'm hoping that you're looking at your papers and saying, yep, that's what I had. We're all in agreement. Makes sense. Logical. All that good stuff. All right. So once we've done that, we end up with x squared plus x over that common denominator equals 2x plus 6 over the common denominator. And once we get here, did you guys recognize this is the point where we can now multiply to get rid of all the denominators, right? So technically what I'm going to do is I'm going to multiply by x plus 1 times x plus 3. This would cancel with all of those. And I'm then left with x squared plus x equals 2x plus 6. A lot of you got to that spot pretty quickly. It's great. And there was a little bit of concern, a little bit of struggle from there on out. Did you recognize that it was a quadratic? And that's the kind of the key thing. So if you get to standard form, you would have x squared minus x minus 6 equals 0. How many of you factored that? I saw a handful. 1, 2, 3, like 3 of you. The rest of you use the quadratic formula? Okay. In my own personal thoughts on this would be I would probably factor, just because for me that's easier, but for you that might not have been easier, and so you did the quadratic formula, and that's fine too. So x minus 3 times x plus 2 would be the factoring. And when you use the zero factor property, you get here, and you get here, and there. Anybody go back and take their answers and double check them by plugging back in to see if they really did work? No? It's good practice. Can you do it mentally real quick? 3 over 3 plus 3. 2 over 3 plus 1. Do they check? Ben says no.
Yeah.
They do? They do check?
Yeah,
I think they both check.
they definitely.
I just wanted to throw that out there that it's not a bad idea to double check and see if things really do or perhaps don't work. Let's wrap this one up. You're doing great as far as I can tell. Any last little follow-up questions? All right, so take a look at number 2. Let's kind of do it similarly to what we just did. If you wouldn't mind, work with a partner. See what you can do with number 2. Okay. See where this leads you. Hey guys, why don't you hop back to your seats? Hey, again, walking around, I'm seeing a lot of excellent results. I'm very, very encouraged by how you're doing. So let me just show you one solution here. Hopefully we all agree, and then we'll figure out how we're going to finish off our class. So maybe one of the tricks to this one, did you see how on at least 2 of them it seemed like there was no denominator at all?
Yeah.
So if there's not a denominator written, we know that it really is a 1. So if you wanted to write that in, you certainly could. But then once you did that, hopefully you'd realize that the least common multiple of all the denominators is x. Okay. So if I were then to try to get to that common denominator, I would need to do some multiplyings and such. So for the first one, what did I need to multiply by?
It's frozen.
Oh, thank you again. I don't need to multiply by x. I need to multiply by x over x, right? So top and bottom. So times x times x. What about that second fraction? What do I need to multiply by there?
Nothing.
Yeah, times 1, or just, leave it alone. And how about the one on the right? Times x times x. Very good. Okay, so then we end up with x squared over x minus 63 over x equals 2x over x. And this is that part where we can actually get to an elimination of those denominators. So we'd multiply everything through by x. This would cancel with all those. And amazingly enough, we end up with, once again, a quadratic, right? So we're to we need to get it to standard form, but then we'll have to decide, do we want to use the quadratic formula or factoring? How many of you use the quadratic formula here on this one? Raise your hand. Definitely a little more than half. The rest of you guys use factoring? Again, they're both valid. They both work great. Again, I see this one as a factoring, like the numbers just kind of jumped out to me. It'd be x minus 9 times x plus 7. So following the zero factor property, I go here and finish with there. Did y'all check your answers and see?
Yes, I did.
And they both should work. I think they both work fine. Okay. So those are my 2 primary examples, and if you're tracking with me and tracking with each other, I think you're in a good place. The way we're going to finish this out as far as this final concept is tomorrow we're going to we'll look at a new slight variation on these, and then next Monday we'll just dedicate that all towards practicing and hopefully get you to as best of a place you could possibly be as we wrap things up. I originally I figured we'd have 15, 20 minutes left here at the end, and we got about 18 minutes. I originally had planned on doing some work at the board, but I'm kind of tempted to change my mind and say work on WebAssign, work on your homework. Save you a little bit of time. Is that okay? Grab your phone, grab a computer. We hardly ever do this, but maybe this is the right day to do this.